Hello guys, and welcome back to another reviewer. This one's for the second assessment for math, and I'm in a bit of a time crunch. The deadline's 11 p.m. I need to pick up someone from airport. So let's start with the basics of polynomials. So polynomials. So first and foremost, let's start with the like and unlike terms. So like terms versus unlike. So like terms are when the terms have the same variables and the same exponent values. So let's take, for example, negative 4x squared and 6x squared. Now they're both the same because they share the x squared. So as you can see, they both use x and they both are raised to the power of 2. Same thing with 10x and negative 5x because they both use x. And same with x cubed and 9x cubed because they're both x cubed. However, there's also something called unlike terms, which is they have either different variable letters, so x or y, and then or different exponents like negative 4x squared and 6x. Now, although they use the same x, one is squared and one is not, so that's why there's not like terms. Another one is like 10x and negative 5x raised to 4. Once again, different exponents. It's pretty self-explanatory. So using these like and unlike terms, you can actually simplify following expressions. So simplify. So let's take, for example, 8z squared minus 5z squared plus 3x. So as you could see, we both have some z squared over here. So that means we can just subtract them. So 8z squared minus 5z squared is 3z squared because 8 minus 5 is 3. And then we can just copy the 3x. So yeah, that's basically how you can simplify. You just need to look at if the exponents are the same, and that's it. Let's try another example. So 3xy plus 3x minus y plus 2x. So this is a bit of a trickier one, but as you can see, we only have one like term here. It's the 3x. So 3 plus 2 is 5. So 3xy plus 5x minus y. So that's how you simplify. So remember the FOIL method. Lastly, let's recall the FOIL method. So let's try 2x. So let's try 2x plus 3 and then 5x minus 8. So FOIL means first. So first is this one. So it's going to be 2x times 5x. That's equal to 10x squared. Next, we do the outer. So outer is the 2x again, but this time it's the negative 8. So 2x times negative 8 is equal to negative 16x. The next, we have the inner. The inner is going to be the 3 times 5x. So 3 times 5x. That's equal to 15x. Oh, sorry, this should be negative. And then lastly, we got the last, and it's like this. So it's going to be 3 times negative 8. That's equal to negative 24. By listing down all these expressions, we get a 10x squared minus 16x plus 15x minus 24. We combine like terms, so we have to combine these two x's. So 10x squared minus x minus 24. So that's a FOIL method for you. It's a grade 9 reviewer. Okay. So, what makes a polynomial? So basically, you have to watch out for these ones. So if the expression is just like if the expression involves like something like this, so not a polynomial. So first and foremost, let's take 8p raised to 1 over 12. So if it's not integer, it's not a polynomial. So the reason, because I think it turns into an irrational number. So that's why it's not a polynomial. I'm not so sure, but just look out for that. Next, we have 2 over, let's say a. 2 over a is not a polynomial because variable is in denominator. So the reason why it's not the reason why this is not polynomial is because if you try to like just make it in terms of a, it becomes like a raised to -1, -2, something like that, because you're taking the reciprocal of it. So that's why, yeah, in this case it's a raised to -1 because we took the reciprocal of a over 2. So that's the reason why. Another thing to look out for is square root of x plus 2. Variable in square root. So the reason why this is also similarly is that since this is a square root, it actually can be simplified to x over 1/2. And once again, as you could see, it's not an integer, so that breaks the rule. So other than that, just look out for that. Okay, next one, it's the degree of the polynomial. The degree of the polynomial is the highest non-negative integral exponent of the polynomial. So degree, let's put degree. So in this case, let's try 6x raised to 5 minus 4x raised to 4 plus 15x raised to 3 minus 12x raised to 2 minus 35x plus 28. So the degree is simply the highest exponent. So in this case, the degree is 5. So you just need to look for the highest exponent. So this one's actually just this is actually just a reviewer, but this is what you call the degree. Okay, so first and foremost, for 0 it's constant, for 1 it's linear, for 2 it's quadratic, for 3 it's cubic, for 4 it's actually quartic, quite a weird term, quartic, and lastly for 5 it's quintic. It goes on and on, but like these are what this is the one in the presentation. So yeah, this is the most you'll need. So, and lastly, how do you call a polynomial? So 1 based on how many terms? So we have 1, 2, 3, 4 is called number 1 is a monomial, number 2 is a binomial, number 3 is a trinomial, and lastly 4 plus is a multinomial. So once again, it's pretty self-explanatory. About the term. So once again, yeah, you just need to count how many terms you have. So terms is like this one. Terms is this one, by the way. Okay. Lastly, standard. I think this is the last. I'm not so sure. Okay, we're getting closer. Okay, standard form. So standard form is when all the exponents are lined up in proper order. So I'll use a shorter example here. So let's convert it to standard form. So negative 8z plus 2z3 minus 7. So to convert it to standard form, sorry, let's put z squared there. Okay, so to put it into standard form, you need to first find the highest exponent. So that's 2z3. So put it at the front, then the second highest exponent, and so on. So the second highest exponent is negative 8z squared, so we can just attach it here. And then lastly, negative 7 stays at the end. So as you could see, it went from 230 to 320. So it should be descending order. Let's try it again. 2y raised to 5 plus 2 minus 2y raised to 4. So in order to convert it into standard form, 2y raised to 5 is already there, so it's correct. We just need to swap the last two terms because 4 is greater than 0. So negative 2y raised to 4 plus 2. The reason why I said 0 because there's it's a constant. It's a constant. There's no variable. All right. Next, literal coefficient. So literal coefficient is just this one. So like 6x raised to 5. It's just this one. Okay. Now, how about if it's let's go back to degree of a term with more than 1. So let's say 6x raised to 5 y z raised to 4. What's the degree of that? So basically, you just need to add all of it. So 5, x raised to 5 is 5. Y raised to nothing, so it's just 1. Then z raised to 4, so that's 4. 5 plus 1 plus 4 is equal to 10. So that's it. So you just basically need to analyze it. So how about numerical coefficient? Numerical coefficient is just pretty self-explanatory. It's just gonna be the numerical coefficient. So this one. And lastly, the leading coefficient. The leading coefficient is just the one with the highest degree. So the highest degree is always your leading coefficient. So okay, that's lastly. So lastly, evaluating polynomials. Evaluate. So let's evaluate 5x cube y and then z raised to 4, given that x is equal to 2, y is equal to 1, and z equals -1. So I'm going to show you how to type it in the calculator. So first and foremost, we need to, let's substitute. So 5, and then x is 2, so in parentheses 2. I'm going to use the two-line calculator format first, because I think most of you use two-line. So then you raise to 3. Yes. And then 2 raised to 3. And then what I usually do is just keep that for now. Then times that by times that by 1, -1, then raised to 4. So what I do if I'm using two-line calculator is just to evaluate these separately. So let's put 5, 2 raised to 3. So that's equal to 40. And then 1 is just equal to 1. And then -1 raised... Oh, by the way, make sure to put the parentheses in the -1. Otherwise, you might have a different answer. So parentheses -1 raised to 4 is +1. So 40 times 1 times 1 is 40. So that's how you evaluate. If you're using four-line calculator, you can just use the one shown in the presentation, which is like this. And it should give you the same answer. Let me just try that out. 3 times 1, -1 raised to -4. Yeah, it also gives 40. So this also works. So that's all you need to know for the basic concepts of polynomials. That provides everything. So next I'm going to start with the division of polynomials. This is not really that complicated actually. Actually, long division. Just realized that, yeah, long division can be explained with 2-3 examples. Same with synthetics. So I don't know why I'm rushing for. So I'll take it slowly. I still have an hour, 15 minutes. Okay, let's start. So first and foremost, so let's start with divide. Let's say -12 plus 2x plus x squared by x minus 3. So first and foremost, before you divide, you have to arrange it in standard form. So x squared is first, followed by 2x, followed by -12. And then you just put the divisor over here. Okay, so we just need step 1. That's step 1. Step 2, let's divide the first term. of the dividend. This is our dividend by the divisor. So x squared divided by x. So x squared over x is just x. Next, multiply this x by both terms. So how do we do that? So first we got x times x squared. So that's x times x over here. Then next, x times negative 3. That's negative 3x. Very good. Put this in parentheses. Then we just need to minus it. So x squared minus x squared is just cancelled out. 2x minus negative 3x. So put that 2 minus negative 3. That's equal to positive 5. So 2 minus negative 3. That's equal to 5x. And then we just bring down the next term. 12. Negative 12. And then we can just repeat the process again. So let's get the 5x. 5x divided by x. That's equal to... 5x divided by x is equal to 5. Then 5 times x. That's 5x. Then 5 times negative 3. Right? Yeah. 5 times negative 3. Okay. 5 times negative 3 is negative 15. So, let's try to subtract that. So, 5x minus 5x, that's nothing. And then, negative 12 minus negative 15 is equal to 3. And there you go. That's the answer. X plus 5 remainder 3 over x minus 3. So if you end up with this one, right? This one is 0. That means it's a, what do you call this? That's a fact. It's exactly a factor. So yeah, that's the division algorithm. So let's try to use a trickier example. Divide x cubed minus 2 by x plus 1. You might be saying, oh, this has less terms than the last one. Why is it harder? And it's even in standard form. Well, it's because, as you could see, it's missing some terms. As you could see, x cubed, and then it immediately jumps to the constant. What do we do in this scenario? So x cubed, right? We don't have any x squared. So we just put minus 0x to x squared, minus 0x squared to consider that. Plus 0x. And then same thing here, plus 0x here again, because we don't have any x. We do have negative 2, so we can attach that there. Then just put our x plus 1 over here. And we do the same process again. Step 1. X cubed divided by x squared. X squared times x. X squared times x is x cubed. X squared times 1 is just 1x squared, or simply just x squared. Subtract. So this will be cancelled. Our x cubed will be cancelled, and this will be negative x squared plus, bring down the 0x. Same thing, repeat it again. Negative x squared divided by x is negative x. Negative x times x, negative x squared. Then, negative x times 1 is minus 1x. So, let's simplify this one. So, negative x squared minus negative x squared. That's just going to cancel out. And then we got 0x minus negative 1x, which is just positive x, or positive 1x. And then bring down the negative 2. We're almost there. 1x divided by x. 1x divided by x is 1. Then 1 times x, 1x. 1 times 1, 1. Divide, finish subtracting. So negative 2 minus 1, that's negative 3. And that's our remainder. So the final answer is r, what's this? 3 over, sorry, negative 3 over x plus 1. So yeah, that's it. That's our final answer. Yeah, you can just actually remove the r and attach the term. So basically, if all terms are completed, good. You can skip straight away to the divisor part. But if some terms are like missing in this case, we need to fill them up first. So it's that simple. That's long division. So now we have to, now what if we don't want to do that? What if we have something like, let's say, raised to 6? What do we do? Oh, we need to give that the box. So long division. We covered long division. Okay, synthetic division time. So synthetic division is just like a shorter way of how do I say this? Dividing. It doesn't give you this long mess that is so prone to like screwing up actually. Even I get it messed up sometimes. So I'm just gonna load up the reviewer. Okay, and I'll start. Synthetic division. Personally, I feel like both of them are easy to mess up. So you have to really take it slowly. So let's go through this together. So synthetic division is a shorter and faster way. So basically, you can divide anything as long as it's like any like, what do you call this? Okay, I might as well just show it to you. So let's say 12x cubed minus 2x minus x plus 4 divided by x minus 2. So it's this synthetic division. What do I call this? It gives us like this very simple way of doing it. So first, let's look at our divisor and take our literal, since it's in standard form anyway, we can list the coefficients accordingly. So 12, then negative 2, then negative 1, then 4. Then our divisor would be, so x minus 2, right? Your divisor would be what value of x will make this 0. So in this case, it's 2, positive 2. So draw it like this. Step 1, bring down the 12. Step 2, multiply the 2 and the 12. That's equal to 24. Step 3, add the negative 2 and 24. Repeat. Once again. 22 times 2, 44. Add the negative 1 and 44. 43. Once again, do it again. 43 times 2, 86. 86 plus 4, 90. It's very simple. Much more simpler than this one, right? So how do we format it? So we have to format it like this. And then we want to take we want to take one less exponent from here. So instead of 12x cubed, it's 12x squared plus 22x plus 43. And the remainder is 90 over x minus 2, because that's our divisor. So you could see very self-explanatory. But what if, once again, just like in long division, what do we do if there's a missing term? Like, let's say there's no like kx. So let's see. 3x cubed plus 4x squared plus 8 divided by x plus 2. So obviously it's in standard form again, so we can put 3, 4, but we do not immediately write 8. So we have, this is for x cubed, x squared. So we need to put this one for x, 0. Then we can continue with our 8. Nice. Then once again, equate this to 0. So x plus 2 equals 0. So therefore, x equals -2. Okay. Let's do this. Drop down the 3. 3 times -2, -6. 4 plus -6, -2. -2 times -2, 4. 0 plus 4, 4. 4 times -2, -8. 8 plus -8, 0. So if this is 0, there's no remainder. 3, so therefore our answer is, since we started with x cubed, this will be x squared. 3x squared minus 2x plus 4. Very good. So that's really it. That's really it for synthetic division and long division. It really is that short. You just need to master it, and I'll be happy to give you more examples if you ask me via DMs, and I can explain it for you. I can give you more examples. Lastly, but not the least, remainder and factor theorems. So remainder and factor theorems is an ultra shortcut that just gives you the remainder, and it verifies if it's a factor. If the polynomial is a factor or there's a remainder of something when divided by the divisor. It sounds complex, but I'll just put it very simple. The process is both the same. So let me just find our reviewer for that one. Yes, I'm reviewing the reviewer. Okay, looks like they haven't posted the reviewer. But let's try to use the remainder factor on our previous example here. So 3x cubed plus 4x squared plus 8 divided by x plus 2. So you want to check if this is let's say a factor, like this is like x plus 2 is a factor of this one. So all you need to do is first and foremost equate this to 0. So -2. So x equals -2. And then we can just evaluate it. So let's put it into parentheses. So 3 raised to -2. 3 times -2 raised to 3 plus 4 times -2 raised to 2 plus 8. Let's put that in our calculator because we just subbed it in. So we 3 -2 raised to 3 plus 4 -2 raised to 2, and then plus 8. So when you equate this one, if it results into, it should result into 0. And in this case, if it's 0, it's a factor. So this is a factor of this one. Same thing for remainder theorem. Let's use this one. So x cubed minus 2 divided by this one, x plus 1. So once again, equate this to answer to 0. So this means x equals -1. So therefore -1 raised to 3 minus 2. Put that in your calculator. Parentheses -1 raised to 3 minus 2. You should end up with -3. And just like how we did long division here, we ended up with remainder -3. And in this case, this is the remainder. Now, the best part about this is that this can be applied to these extremely high order polynomials. Like let's say x raised to 85. You're not going to long division. You're not going to synthetic division that. You're not going to do that. You just have to just use this one to find if it's a factor or a remainder or not. So that's pretty much it. that's pretty much it. Wow, I have an hour to spare. I was worrying I wouldn't make it in time. I made it in 30 minutes. Oh my gosh. Oh, the best part about this, I just realized there's no application. There's no application. Oh, this is awesome. This is an awesome unit. Anyway, guys, thank you so much for sticking with me. I know it took a while to get here. Busy schedule. I have 2 competitions tomorrow. But once again, please take care of yourselves. Study well, study hard. And I'll see you guys in the next one. Bye!